Okay. All right, you guys ready? Okay. We are finally ready. Hi, Denali.
7
Everybody
foot.
can say it. Yay. We miss you. Okay. So, we're finally ready for the first fundamental theorem of calculus. Hooray.
The first?
The first fundamental
I assume we should write this down.
theorem. Fundamental theorem of calculus.
Only took us a semester to get here.
Yay! FTC part 1. Okay? The integral from a to b of f of x dx equals capital F of b minus capital F of a. Now, we're going to talk about this for a little while. Remember our 3 different types of position from last class. We have Miss Summers' Fitbit, which counts all the walking done no matter where, which direction it goes, right? That's area, that's total distance traveled. Fitbit, regular area, total distance traveled. Then we have what I would see on a map, right? The actual distance from my classroom to the front office, okay? So map distances, right, are signed area, which is displacement, which is the integral, right? Okay, then the third one is my actual GPS coordinate location, okay? That's not an amount of distance like the other two, it's physically where I am, right? In order to have that, I need an origin, right? Graphically, our origin is the origin, right? In the world, our origin is, I don't know, where the hemispheres meet or something. Where's 0, 0? For latitude and longitude.
I believe it's where they're
Is it? I don't know. So then is there 2? I don't know. Right?
I think it's for the equator.
Equator meets the line of something. Who cares? It doesn't matter. Not the point.
Now I care though.
Okay, I know, me too. I'll Google it while you guys are working on something. Okay, so anyway, so those are our 3 types. Now, this one, total area, so total distance traveled, not represented here, right? My displacement, my change in position, right? My signed area, that's here, that's the integral, right? Is the end position, my actual GPS location, represented here? Yes, it is. What is it?
It's the FB ones.
Nope. That's the same as the displacement. Yes, F of B. F of B, I want you to imagine like on a graph, I've got some random function,
Yeah.
right? This is A, this is B. F of A is my starting position, right? And F of B is my ending position, okay? So what I want you to imagine with this is that this is my change in position, which is equal to my ending position minus my start position. Okay? Let's say I had a little brother, and let's say he had a growth spurt over the summer. Okay, we went to the doctor over the summer, and he was 6 feet tall. We went to the doctor, 6 feet tall. We went to the doctor at the end of the summer, and he was 6'8", 6 feet 8 inches. This is not a real story.
8 inches in
right.
3 months.
So his end position, how much did he grow during his growth spurt? Height at the end of the summer, beginning of the summer, height at the beginning of the summer, height at the end of the summer is how much his growth spurt is, right? Ending position minus starting position equals my change in position. Now, some people prefer to look at it like this. So if you do, then write it this way. This is just how you're going to see it in a book, okay? But some people prefer to memorize it like this, which is great.
Oh.
Right? Because to them, to think about it instead like start plus change equals end.
That doesn't make sense.
Great, right? Same idea. Okay, so however you want to memorize it. Just know that this is how it would look in a book or if you looked it up online. Okay? Start plus change equals end, right? The change in something is equal to the ending minus the start. Yes, Isabel. Because the area is the area under a velocity graph, remember. Notice these are the lowercase, and these are the uppercase. So my change in my position is my area under a velocity graph. Okay? Remember the area under velocity, this would be like a miles per hour. This would be like in hours. So when I find the area, which is base times height, right? Miles per hour times hours, I get miles, I get position. The area under a velocity graph is position. Okay? We good? Now, how are we going to use this? Okay? We're actually going to use this in connection with what we did most of December. In December, we made sign analysis charts on velocity graphs and equations to find where the possible extrema might be. Where's the possible absolute max, absolute min, relative min, right? Well, now I'm going to be able to find not only where those possibilities are, but what the actual y output of it is. Because now I can solve for positions given velocity. Okay? So that's where we're going to start, and we're going to start together. So the first thing we're going to do is we're going to make a sign analysis chart that represents this velocity graph. So we're going to take 30 seconds with your neighbors and discuss what you think the numbers to put on the sign analysis chart would be. Sign analysis chart, those are those number line things.
Mm-hmm.
Okay? So 30 seconds with your neighbors. What numbers go on the sign analysis chart? Okay, go. 4.
I'd say
It would either be 3, 7, 10. 3, 7, 10.
Hey,
Because that's
anybody
where
have any
it
thoughts?
crosses the x-axis.
What are the, okay, reminder, on my sign analysis chart, what goes on there are the endpoints of my domain and my critical numbers, right? So what are the endpoints of my domain?
3 and 14.
Yes. And what are my critical numbers?
7 and 10.
7 and 10. Good, the x-intercepts of my velocity graph. Okay. Is my velocity between 3 and 7 positive or negative? Positive. Then between 7 and 10, it's negative. And between 10 and 14, it's positive. So here's my sign analysis
That's
chart
the
for my
crying
velocity
man.
graph.
That man looks hot.
Okay. Any questions? You okay?
I wanted to say that, but it's easy.
Well, it's the velocity graph. It is easy when I give you the velocity graph. It was harder before because I gave you position graphs sometimes, right? But when I give you a velocity graph, it should be easy because my sign analysis chart represents my velocity graph, right? Okay. Okay, so now what I want you to do is take 30 seconds with your neighbors and decide for me where are the possible relative maximums and absolute maximums. Where are the possible relative maximums and absolute maximums? Okay, so 30 seconds with your neighbors.
No, relative maximum is where. So 14 is an absolute maximum. And
You guys,
then
wait, remember, I'm asking about the relative and absolute maximums of the position, right?
this is the
I know the
velocity.
maximum of the velocity, it's 4. That's easy, right? We're looking for the absolute maximum and relative maximum of capital F, of position, okay? Good?
Wait, what?
One is this graph and one is the graph we don't have.
Oh.
It's definitely
We have velocity.
Technically,
Yeah, this is
oh, are we only doing the
so
maximum?
what we need is we need the position graph.
Absolute
throughout the action.
maximum and relative
So,
maximum.
Okay, we're just doing maximum, right?
Seven.
Minus right?
Wait,
Seven
no, first.
is positive to negative.
I was
Seven.
thinking.
7 is a relative maximum, and 10 is relative minimum.
I'm gonna say the
Maybe.
Yeah. Yeah. Yeah.
No,
What about the absolute?
because that'd be a jump. Wouldn't it? Am I smoking?
No? Wait. Where would we jump? Oh.
This is increasing, so we'll need that side.
I gave you a hint in the way I wrote what I wrote on the board. Anybody notice that? One says possible and one doesn't, which means we have enough information already to know where the relative maximum is. But we don't know, but we have two possible absolute maximum.
And it could be 7.
Okay, 10 more seconds and then we're gonna go.
Why would it be 5?
Combo dying down. Okay, does anybody have any thoughts? Can you raise your hand and tell me your thoughts? For either one, I don't care. Anybody?
5 is in the middle of the slope.
I heard talking.
Well, we're thinking that 14 is the absolute max.
It's a possible absolute max, I agree.
7 and 14 are the possible absolute.
Yeah, because we don't know if the graph looks like that or like that.
So the relative would have to be
So the relative has to be where?
14.
No,
Ah,
7.
7.
At a 50-50% chance.
No, 100% chance. What's a relative max? It has to have the shape
Yeah.
of that U. It has to see both sides. We have no, if this was a relative, then remember, we would have to know that it goes down after. We don't know anything though, right? It could be in the middle of an increase. We have no idea, right? Okay. So the relative max location, not what it is, but its location is 7 for sure. But what we don't know is if the 7 and 14, which one of these options it is, right? So now what we need to do is we need to find those. So in order to find those, I need to find f of 7 and f of 14. Okay, so using our first fundamental theorem of calculus, did you guys care, or I feel like I heard mumblings that most of you like this version? Yes or no? Or do you want me to do the other way? Do we care?
Yeah, just,
We don't care.
Yeah, just do it.
I just didn't know which version you like to look at. They're the same thing. That's good if you don't care. That means you recognize they're the same thing. Okay. So f of 7 is f of 3 plus 3 to 7 f of x dx. This is what we need. This we need to be given. Can you fix that? It slid a little. It's just looking at the ceiling. Got you back to Nolly. Okay. And anyone else watching. Do we need to put something in front of it? So it doesn't slide or something?
And I think it just needs weight.
Okay.
That's the start.
Here.
I just don't think the box is enough weight.
Yeah, the box is moving back.
Yeah, we're trying to
Has it been staring at the ceiling the whole time?
No, because I had checked just a second ago. Okay. Okay. This is what we need. This is what we should have been given. We don't have enough information to find it. You're almost always at first, at least, given those. I just didn't give it to you before because I didn't want it to confuse you yet. So I'll give it to you now. So let's say that my initial starting position is 5. Okay? So we need to find what the area under a graph from 3 to 7 is. Okay? So do that.
She said so.
Seven.
I got 7. So now, if I asked you not just the location of the relative maximum, but I asked you what is the relative maximum's value, you could tell me 12, right? So 7, 12 is the relative max. This is where, and this is its value, okay?
Could you go over that again, but in very much like extensive detail?
I don't-
I don't really understand.
Which part?
The where do you get 7?
That was here.
No, the 5 plus 7.
Oh, this? Sure. I took this, because that's 3 to 7,
Yes.
and then I split it into a rectangle, which was 2 by 3. So its area was 6. And then a triangle, which is 2 tall and 1 wide. So the area of this trapezoid looking shape is 7. So that 7 represented the area from 3 to 7 on the graph. And then the 5 came from the given initial starting value.
So like the point where it starts, where it like goes up to, that's 5.
No, because this is a lowercase f graph. On the graph we don't have, on the position
You're
graph,
right.
which is why I had to be given this.
Oh, okay.
No, thank you. I'm sure you were not the only one. Anyone else?
So what is uppercase versus lowercase?
Lowercase is our derivative, and uppercase is our position. Lowercase is the velocity, uppercase is the position. Okay? What else? Tyson, can you go with the ruler away? Yeah, you can grab links while you're at it, thanks.
So now we have like f of x.
Good? Okay, now I want you to find
It's just
f of 14 for me.
That's what the position graph is. F of 14. Yeah.
Because yeah, we know our relative max, but we still don't know our absolute, right? So I want you to now find f of 14, capital F of 14 for me. What's your neighbors?
So that's 8.
With your neighbors.
I don't have neighbors anymore.
You know about these neighbors. Okay, hon, you're ready.
Because that's our A of our domain, right?
1, 2, 3. Wait, wait.
It's lower. Oh, it's not lower. It's a different graph.
No.
Everything's random.
Maybe it is 16. Supposed to be that.
Yeah, it's 14.
It's supposed to be. It's supposed to be a derivative.
Are you guys done already?
Okay, no. So what she said was that just the lowercase f was a derivative graph, and the uppercase f was the position graph.
Okay, so what is my starting amount?
So you need to write it like this, not like this.
Area from 3 to 14.
Is 9.
9.
Not like that. No, this means derivative. This means that's interesting.
Sorry, no.
No, you're not.
So, where is the actual absolute maximum? And what is its value?
14.
Anyone have any guesses what I'm going to ask you to do now? Same thing, but for minimums. I want to know the possible minimum locations. I want you to find where is the relative minimum, where is the absolute minimum, and then find both of their values. Okay? You know where the 5 came from? You know where the 9 came from?
Yeah, it's different. We
This
just learned it.
is the
Area
position.
of signed area of all of
The
these.
lowercase.
Or 7 plus this area minus 6
Yeah.
for this area.
Yeah.
Yeah, it's
Because
that.
that's
She
the
just
area,
replaced
signed
the
area,
prime of x
3
with
to 14 on
lowercase
the
f
graph.
of x.
She's not like it. That's what
Mhm.
I said. I guess girls. Then he asked you again, and then you're like,
We're finding the. Yeah. We're doing what we just did with the maximums, but for the minimums. The relative minimum and the absolute minimum.
oh,
We're already given.
what is this one thing? What? It's the last that you choose it. Any comments?
The password is the same, and when you're done, if you could just staple them all together, because I'm not gonna.
The relative minimum?
I haven't done
Yeah.
Oh, we
I
do
should've
that
just
by
opened
using
it
the
at
number
least.
line chart. Remember?
Yeah.
Because when it goes from positive to negative,
And
that's
while
our
you're
relative
here,
maximum.
if you wanted
When it goes from negative to
to
positive, that's
give
relative minimum.
yourself a try on the portfolio quiz, that's not a bad idea, so. This one's worth so much more, so let's focus on that.
absolute?
Or to get 8.5. The absolute, you gotta do the, because look at what she did for the shape of the graphs. We don't know which one of those it is. Like, we don't know whether this bottom part's lower or whether this part's lower. But what we need to do is we need to find the values of,
Just to help your explanation.
yeah.
Dig.
We need to find the values of 3 and 10. to be able to figure out which one of those is higher than the other. So we do what we just did with the f of like 7 and that, the integral stuff, and then we just do that with the, what are you doing? With the minimum, the minimum values instead.
Are you guys done? It's so, really?
Well, yeah, there's only one thing to solve for because you're given the other one.
Ah, very good. Some people get in robot mode and they start solving for the other one too, so that's good. Okay, so the, oh, this is my, okay, so the possible minimums are 3 and 10. The relative minimum for sure is 10.
I was like, wait a minute. Did I do something wrong?
No.
That's what the guy who shrunk my head said.
Why is it 3 and 10?
3 because after 3 I increase, okay? And then 10 because it goes negative to positive. And negative to positive derivative means decreasing to increasing original, which means minimum. Okay? So we just have to find 10. Okay? And good. Okay, so let's go f of 10 is 5 plus 1. So f of 10 is 6. This time, are we wanting it to be the bigger or the smaller number?
The small one.
Good. So this time, 3 is my absolute minimum, right? And its value is 5.
Swedish.
Okay. So we know the domain A to B on this one is 3 to 14, right? Could you tell me the range now?
That's Ms. Hyderberg.
5 to 14. I think the max value was 14, right? Good. Okay. Here's what we're gonna do now. You guys have your worksheet from last night
Yeah.
still? I want you guys to find for me the absolute max and absolute min values of the graph up top on your
I
worksheet
put
from
it on
last
this. No,
night.
I put it on this side.
Okay?
The absolute max and absolute min.
Yep.
So they're not giving points.
I'll make one up. How about the starting point? F of negative 4 is 2. Okay.
Where does the what come from?
This is for the practice. F of negative 4
that's when
is
we
2.
solved for 7 using the
Oh,
fundamental.
I want the
theorem.
that's not part
absolute
of that.
max value and the absolute min value.
Number line, -4. Dos. 6. 10. Wow, that's a horrible amalgamation of English and
Negative 4 to 10.
total? I thought so.
Okay, so we got 0, that's 2, bounce,
-4 equals 2.
No, that's not that.
Let's see. Okay, we want to find absolute max and absolute min.
It's 3. No. What? The whole number is 3. The half of it is 2. But why do I need that? I'm not doing
What?
that right now.
Huh?
Wait, what are we doing? So
Well, we're doing what we just did, but for the worksheet we did last night. This graph.
The show up. What?
We're doing what we just did in class, but for this worksheet.
Just so I didn't have to draw another graph. You guys already have a nice one.
Oh, got it.
Guess what we start next week? What if they're not nice shapes? What if it's a sine graph or a polynomial? I think that stuff's kind of fun though.
Stop it.
You'll see.
You don't need credit. Oh, I just kidding. No. What? Wait, you tried to find the maximum.
Well, I guess you could also consider 14 as 4.
I know. Curtis, are the values for the sun this thing? Negative 2 and 6.
Pardon the interruption. Could I please have Kate Whitaker for checkout?
Sure, thank you.
Sweet. I don't know why she put 4.
Take the homework's right here.
What is that?
I really don't know why she put 4.
Oh, will it be on the Okay.
So is it 4 or 2?
I think it's 2. She said 4.
She said it's 2. But the, what is it for? The starting position is 2. What? It's, no, on this. Oh, for that. Is it 2 or 4?
I think it should be 2, but it's
Oh,
not.
I got it.
I don't know why.
It could be a possible.
That's weird. No, it's not. Perfectly normal.
You know what else is weird?
You.
I mean,
Okay, I got 2 and 10 for my possible minimums and negative 4 and 6 for my possible max locations. Oh, yeah, that's good. And negative 2 isn't a possible anything because there's no, it's a bounce. Yep.
Yeah, probably.
No, I mean like doing this stuff. That's what I asked. No, we're doing right now, but it's like the same math. Did you already do the homework? No. I'm not. You can.
We're not.
Cleo. Go. The conversation.
Did you watch that show?
Huh?
Did you watch that show?
No, but not this one.
Wait, so I have to know, how do they do latitude and longitude?
There's a name of a line that's like through England.
Oh, the meridian.
Yeah, that's what it's got to
The
be.
prime meridian.
Yeah.
Primer, yeah.
I only needed one of the words. And then I would have gotten the other one.
Yeah.
Huh?
The origin point is where the equator meets the prime meridian.
So basically, I made a signing house interesting find this one
I think it's somewhere in Africa.
and then using
It's just Dominican Republic.
Yeah, that makes sense.
Which has nothing to do with English. So actually, maybe I'm reading something. I don't know.
Just 6. So there's just all
Wait, so is this
Huh?
is this from the
Yeah, she already gave us that one. It was there.
Oh.
Maybe 4 equals 2. You guys are distracting me.
Curtis, we're distracting you.
doesn't count.
Yeah, you're distracting me.
Right, so this one's going from negative to positive, so...
It's way harder to do. Where is it hard? I just
I'm gay for you. I'm gay for me. Spider-Man, why are you gay for this man? I'm not. He's talking silly.
So you determine what's possible.
Did he get his New Year's list that he wanted?
No.
I
I didn't go to him in the first place.
I would have been holding out my room if I were you. Lucas could fly if you needed me.
What's the point of doing that?
Flying into your window.
Okay, yeah, so he just killed me. But he would also die.
On your sign analysis chart.
So that should have been 2.
Okay. Well, I don't have work. Oh my god. Then he probably does.
I remember when I lost my mind.
It's saved now.
Ah.
I've been learning. Good job. Yeah.
I'ma be crazy.
I got one.
I'ma be crazy. I remember when I lost my mind. Ah.
It's actually because you have the F.
You're not calling me working at me. You told me the real
So we just need to look at What did you get?
right before the class starts.
She already said that, but.
F of 6.
So wait, the absolute powers, absolute
Say it without fine. So you didn't fine. You don't need to remember it long term. It's fine.
Alright, F of 6 is 2.
Is it nice?
This is why you write out your. Wait. No, F of 6 is not 2.
Yeah, it's just like,
It's 3 minus 1 subtract.
Okay.
Because mine just says F of 6 equals 2. So I wrote that as the answer.
She learned every student.
All right, you guys, are you ready to see what I got?
Yeah.
Okay, so I got for the one from the worksheet. Got F of 2 is 1 minus 2 pi. I got F of 10
Oh, thanks.
is negative 4 minus 2 pi. So that's the absolute min value.
Yeah, totally.
That's where absolute min. Did I do it wrong?
Oh, no, I have it.
And then for the max, I got the f of negative 4 was 2, which was given. And I got f of, oh, wait a minute. F of 6, I got 4 minus 2 pi. Right? I think I did Which is a smaller number than this. So this is the absolute max value. I could have done it wrong. I did it really quick. So okay. And so then this one is where the absolute max occurs. Good?
No?
We good? Okay. Any questions?
What's the coordinate of the absolute minimum?
The coordinate for the absolute minimum is 10, comma, -4 minus 2 pi. Absolute min. And the absolute max.
Because the integer of
What?
42.
Oh, you're right. Yeah, you're right.
Have to add.
I didn't add the initial.
Yeah, there we go.
You are correct. And then -4, 2 is the absolute.
Yeah, I was like, you said it.
I remember.
Guys, that's it. Your homework is bookmark. I texted it out already. There's about 10 minutes. You can work on it if you'd like. I'm just gonna go show the. Oh no! Wait, I'm not with the AVF stuff. We gotta do that. Pause. Okay. Sorry. I'll just talk about it and then you can do homework. It's not bad at all. Okay, I just want to point out that we have an average rate of change that we've done a bunch of times, right? So I'm given a position and I find the slope between 2 points and that finds for me the average velocity. The average value function is like the inverse of that. It's doing the opposite. So if I want to find the average position, but I'm given a velocity, right? So think about how do I find an average? I add them all up, I divide by how many there are. Well, how much time has passed? So how many are there here? Well, 11 because 14 minus 3, right? How much time has passed or how many are there for this one? 14 because 10
minus
to -4, minus -4, right? Anytime I want to find out the total of how much something was, you take your domain and you subtract them. So this is like adding up all the areas and then dividing by how many there are.
Why is it 1 over that?
Because it's division, timesing by a fraction, like division.
So you do 10 minus 3? Or
Huh?
14 minus 3 for this one?
Yes.
And then we do
So and then I take the area, signed area of the whole thing, and I divide it by the 11, and that's going to give me the average value for it. Is that good? I think that's good. There's a couple in your homework, so okay. Now you can have
Guess we'll figure it out.
free time. Good job.